Hello. During my research, I realized that I cannot do everything by myself. And I like to draw inspiration from these fire ants, who work together as a community to solve a big problem. And I believe in science we have to do something similar. We have to collaborate to solve problems. And one of the major problems that's heading our way is the increase in data. What you see on the y-axis here is the total volume of public data in the public proteomics repository called PRIDE, and it doubled in 2015. This is very interesting for scientists as we get to reuse all of this data, but it's also making it very hard to handle the data. And this is mainly due to the fact that the reuse of data is becoming more widespread. So it started off by us in proteomics doing this, but then I got involved in genomic studies, transcriptomic studies, and metabolomic studies, while using the same infrastructure. So this creates a processing bottleneck, which is not easily solved. But we made some attempts, and the first attempt was to make a grid engine to distribute the jobs across several compute nodes. So basically we take the data from PRIDE and we delegate it in smaller chunks to these several computers, which all process it in their own fashion, and then project by project we get the results back and collate them in one big pool. Now, we already had this infrastructure, but there's still some surprising costs. For example, we need to account for the power of these machines. They need to be cooled. The data needs to be transferred over a strong network. The data needs to be stably stored and needs to be persistent and redundant if possible. And of course there's the upkeep and the maintenance of the entire thing. So I went out of my way and looked into other resources where I could find this hardware. And I had a look at the cloud. And what I found out is that the price per month for machines to do these computations comparable to our servers ranges between 280 euros and 1,000 euros per month, so it's not affordable. And then I found yet another resource of hardware that's readily available, and I found it on Steam. So this shows the amount of players that are concurrently logged into Steam. Steam is a gaming platform, by the way. And it ranges between 6 million and 10 million, so at any moment of the day there's at least 6 million computers available. And these computers are nothing to sneeze at. I mean, I compared my laptop that I use for work, which is an i7 dual-core, against 3.5 million other computers. And I only ranked in the 42nd percentile, so more than half of these were actually better than mine. And I cannot play GTA 5, so maybe I need an upgrade. And some projects already tap into this CPU power. SETI at Home pioneers this by recruiting 145,000 computers at its peak height. And it had a processing speed that was 50 times faster than Tianjin-2, which is the fastest supercomputer to date. Well, sometimes these problems will be too hard even for computers. So Foldit solves this by not recruiting hardware. They recruit users. And they make users solve puzzles to solve the optimal conformation of protein folding structures. And currently there are 57,000 players on Foldit. Just to illustrate, there's only 1,500 scientists in VIB. And it's part of human nature. So if you make the game, gamers will keep playing it. And gamers will keep trying and trying. They don't give up. But the downside of Foldit, gamers don't want to commit their whole life to changing the world. And for Foldit this is the case because you have to start the game and actively contribute. Now, Project Discovery does this in a different way. It recruits players that are already online and already enjoying their game. So Project Discovery entails the annotation by people for the Human Protein Atlas. And the lady you see here is Professor Lundberg, or rather a gamified version of her. She tells people how to annotate cells. And it goes like this. So on the left side you see a real image of cells, and the green dots, or the green staining, are the proteins. The blue staining is the nucleus, and the red staining is where the microtubuli are. And players categorize these images according to the category you see on the right-hand side. So they make it very simple to annotate these cells. But in contrast to what, for example, SETI at Home is doing and Foldit is doing, you don't just get a position on the leaderboard or a fancy screensaver. Players get way more than this. They get in-game credits, which they can use in the shop to customize their character and customize their spaceship. And customization is a very important thing for gamers. Now, these are still people, and they will make mistakes, so the system is in need of quality control. And this happens by a mandatory annotation of known samples. Other than that, players are only rewarded based on their performance, so the worse they are doing, the less reward they will get. And in the end, or in the initial phase at least, all of these results will be validated against the currently used algorithms. And one of these comparisons you can find here. This is the first day result of Project Discovery. And on the y-axis you see the classification count, and it's a comparison between the prediction algorithm and the gamers. And it's very similar, save for one peak. It's a cytoplasm, and something very strange is going on there. Well, it's also explained already. It takes gamers to game the system. So what happened there is that players started to realize if they annotate everything as cytoplasm, they would still get rewards. So the everything is cytoplasm movement was born. Now, of course, if everybody keeps voting for the cytoplasm, it'll just get boosted. But once this bug had been resolved, it turned out to be a very big success. On the first day alone, there were 400,000 submissions by 23,000 players that resulted in 14,500 tasks to be correctly annotated. And not 2 weeks later, there were requests for a competitive ranking system, and there were tutorials on YouTube. And I would like to close my presentation by this image. Every little light that you see on this picture is a computer screen with a person behind it. And these are 5,000 people crammed into a single arena, joined into the biggest LAN party of the world. They're all playing together. So the hardware is really there. And of course, every collaboration starts within your own lab. And I would like to thank these people, who are the fire ants that keep my research afloat. And without them, I'm pretty sure it would have gone down really fast. So, if you have any questions or comments, feel free to leave them in the comment section below. This was my talk. Bye!